Okay, so we're back to do page 8 of the notes, and I wrote those 4 examples out here. Okay, so we want to simplify these. So in order to simplify them, we basically want to get rid of any roots that we can, take everything out of a radical that we can. Okay, now these examples, everything will come out. We'll see in a little while some examples where not everything comes out, but we can still pare it down a little bit. So if we look at number 1, it's square root of 16 x to the 4th y to the 6th. So what I always like to do, and you do not have to do this, but I always think it makes more sense to me to split this up. And we can do this using that quotient rule, right? So if these are being multiplied under here, I can split them up as long as they each still have a square root. I like to do this just to look at each part separately. So now I'm going to take square root of 16. What number multiplied by itself equals 16? Well, I know that's 4. And it's not going to be in a square root anymore because it's just the number 4. Then I have x and y here. So x to the 4th, remember how it works with exponents, okay? So if the exponent is divisible by the index, then I can do that, and that comes out of the radical. So there's an index of 2, right, hidden in there. So 4 divided by 2 is going to be 2. So this is going to be x squared, which makes sense because x squared times x squared, I'd add those exponents, I get x to the 4th. Y to the 6th, exponent divided by the index is going to be y to the 3rd. This is going to be my answer. What this is saying is this expression times itself would have given me this, which we can check. 4x squared y to the 3rd times 4x squared y to the 3rd. 4 times 4 is 16. X squared times x squared is going to be x to the 4th. Y cubed times y cubed is going to be y to the 6th. It does check. Okay, let's look at number 2. So now I have an example of the quotient property. So I could do one of two things. I could break this apart into 2 square roots and have square root of 75x to the 7th on top, square root of 3x on the bottom. The trouble is, if you think about that, 75 is not a perfect square. X to the 7th is not going to be a perfect square because 7 can't be divided by 2 and get an integer. 3 is not a perfect square, and x to the 1st is not a perfect square. So that really doesn't help us at all. But what we can do is we can simplify what's in here first. So I could have 75 divided by 3 is going to be 25. Think about quarters. X to the 7th over x to the 1st. Remember our quotient rule. When we're dividing expressions with like bases, we subtract the exponents. Now, hopefully you're getting, seeing this familiar a little bit, that you see that this looks a little better. So again, I can split them up just so I'm looking at one thing at a time. Square root of 25 is going to be 5. 6 divided by 2 is going to be 3. Okay, number 3 actually had a little typo in it. So if you can change this was a 4, I think, originally. Change it to a 6. With a 4 in there, it's what we're going to do in a few pages, but we're not quite there yet. Okay, so cube root. So again, I can split it up as long as they're both written as cube root still. Okay, cube root of 27. Again, look back at the first page at those perfect cubes if you want. Figure it out. 3 times 3 is 9 times 3 is 27. So cube root of 27 is going to be 3. Remember, no radical sign. I've answered my question. 6 divided by 3 is 2. 3x squared. Again, what that means is 3x squared times 3x squared times 3x squared would give me this expression, 27x to the 6th. All right, so number 4. I have these two parts. I could take the square root of each one individually. That's mathematically, an idea we can do, except if I look at these numbers, again, none of these are perfect squares. I can tell because these are all odd, so they're not going to be divisible by 2. 20 is not a perfect square, 5 is not a perfect square. So what can I do? I can put them together using that product property. So 20 times 5 is 100. I have x to the 12th. I have y to the 8th. again, let's split it up. Hopefully you're seeing that it looks a little better, right? 100's a perfect square, and the x and the y both have numbers that are divisible by 2. So this is going to be 10, x to the 6th, y to the 4th. Okay. So if you want to go straight from this to this, that's fine. Okay, as I said, for whatever reason, just it works better in my brain to split it up and just look at one part at a time. Okay, so page 9 is also a whole bunch of radicals to simplify. So what I'm going to do is I'm going to stop this video again. I'm going to write those 6 problems up here. I want you to try them on your own. And then I'll have them written up here, so we'll go over them, but it'll be a little quicker because they'll be up here already. Okay, so go ahead, take some time, try all 6 problems on page 9.